Hello everyone, this is Maurizio, editor-in-chief of Embedded.com, and today I am at Embedded World showing in Nuremberg, and I am here, I have the pleasure to be here at Advantech booth with Alexander Fritsch, Senior Product Sales Manager of Advantech, of course. Thank you, Alexander. How's it going?
Thank you for the introduction, Maurizio. Pleasure to have you here. So,
Good.
as you said, I'm Senior Product Sales Manager of Advantech Europe. We are supporting our sales in order to select the correct products for the markets.
Good. So we are at Embedded World. A lot of topics running in terms of embedded technology. So what's new from Advantech?
That's a very good question. There's a lot of new stuff of Advantech. I mean, first of all, we are announcing our big partnership with Qualcomm. Mm-hmm. So with the Qualcomm SoCs, we will have a really huge portfolio coming up this year on that one. And of course, the biggest topic, as you might have seen on the embedded world, is about edge AI computing.
Yeah, of course.
So, and as biggest IPC manufacturer globally, we definitely have a word in that one. So what you will see on our booth here is a lot of different systems based on edge AI, starting from small inference systems to mid-inference systems to really fine-tuning servers which are leveraging edge AI.
So let's talk about edge AI. So Advantech's 2025 vision places a strong emphasis on both, so
Exactly.
edge computing, edge AI, in different vertical marketing, smart manufacturing, so energy, industrial, and so on. So let's talk which are the specific innovation in this regard from Advantech to stay competitive, so to move forward this wave of edge intelligence.
Yeah. As you know, we have a very, very broad portfolio, starting from small hardware platforms to bigger platforms to full systems. And this is what is basically our core competency. And this is what we are also leveraging in terms of edge AI. Because from edge AI, if you think, you have different pillars, okay? You have, let's say, that classical, traditional chip manufacturers like Intel, AMD, Qualcomm now, meanwhile, NXP, everybody is going for AI or AI tiles in their chipsets.
Yeah.
So first option. Second option is you simply add GPU cards, like you have done in the past. We also have that option. So we can add GPU cards either from NVIDIA or from Intel, which are also our own brands. And the third option is, of course, you use additional acceleration cards, like from our partners Halo or Accelera. And with this, you get a really, really huge scalability. So depending on the customer needs and the customer's performance needs and also model he wants to run, we do the consultancy. So we support them by selecting the correct platform and leveraging our core know-how, which is the hardware, okay? And bring this together with our partners in the software part in order to drive edge AI for the future.
What about edge AI for medical?
Edge AI for medical, I mean, this is already present. So typically, let's say more from the traditional part, most of those applications are GPU driven, but you already have it, like in the surgery guidance, like robot guidance. So it's already present. It's nothing new and fancy for them. They're already working on that. And it's a continuously improvement also in medical. Also here you will see different scales, and we also foresee that there might be some ARM-based solutions in the future in the medical parts. Today a lot of the application are vision-based. So for example, you have a camera, you get some data, you do some alignment with a camera, like object detection. It's a human, it's a car, whatever. And this is done on the inference system. And also here it's a wide range of performance which you can need or must use. That can be low end, but it can also be high end. And this is where we are supporting on all of the ends, either on the firmware base or then also on the acceleration base.
So in conclusion, Alexander, just looking forward, we see a lot of robotics, humanoid robotics. So, and talking about humanoid robotics, we have not only embedded computing for sure, but also we should talk about power in terms of motor control and so on. So which are the challenges, or how we can optimize firmware considering the real-time sensor processing in this case? So how do you see the future from embedded computing for humanoid robotics?
I mean, a humanoid robotic, we already think about those fancy robots running around doing your dishwashing, right? But at the end, it's already present today. You have your AMRs, which are also kind of human robots. And for example, Intel's TCC, is one part of that. But if you talk about security, what you also mentioned, it already starts at selecting the corresponding and correct operating system. It makes a really huge impact which system you select as your base in order to drive your then, let's say, fast movements, smooth movements on the robots. So really, this is the first step. And then it comes down, okay, what do I need? Do I need just, let's say, at the inference some processing? Then it might be nothing really fancy which you need. Or if you really want to go all in terms of performance, learning, self-adoption, then you of course also need to scale the system. And this is where we definitely see a really growing demand in the future. A lot of topics around, but do not forget, it's not only about software or hardware.
Yes.
It's always a combination of hardware and software. And this is where we are the perfect partner for.
Good. Thank you, Alexander.
Thank you.
Thanks a lot for your time and stay tuned. Have a good day.
Thank you as well.
Thank you.
Thank you. Bye.